Okay, sorry. Good morning, Trisha, Michael, Zaira, Prince, Lyra, and Ayesa. So, how was your weekend? Okay, specifically, how is the problem set? Patapos na ba kayo or medyo kailangan pa mag-cram mamaya hanggang bukas? Or ayun yung pag-usapan? I was a little bit surprised kasi mino-monitor ko yung submissions ano, kasi wala akong magawa ng weekend so nag-aantay akong mag-check. And, surprisingly parang kakaunti pa actually as of kagabi, isa pa yung nagsasagot ng true or false. So, hindi ko alam kung ayaw niyo ba nung true or false or inaantay niyo lang mag-submit later, alright? Kasi ganyan, yun yung problema dun sa mga ganong items, it's all or nothing. So, yeah, kaya siguro hesitant kayong sagutan. But there's already somebody who submitted it dun sa true or false. Perfect naman siya dun sa true or false. So I think it's manageable naman. Though medyo tricky nga lang yung mga questions. So pagpasensyahan nyo na, alright? So I see, kailangan pa mag-cram. Yeah, some of us works best under pressure. Like me, I love cramming. That's my ultimate skill. So, naantay ko talaga yung deadline bago mag-work. Sorry about that. Nagsabay-sabay ang mga requirements this week. So, yeah. Okay. Then unfortunately, kung nagwa-175, hindi, buti na lang, hindi sumaba yung 175. But those who are taking 175 also under me will have the problem set next week. So, yeah, kaya hindi sila makakapahinga. Pero bayaan nyo na, para sa pagdating ng reading break, ay talagang naka-break kayo. Wala kayong isipin for 155 and 175. Okay? So no judgment dun sa mga hindi pa tapos. We have a deadline for a reason. So hindi ako yung tipo na nagagalit kasi inaantay niyo yung deadline bago mag-submit. Kaya nga may deadline. Yun yung yun yung expected day where people will submit. So yeah, take your time. Meron pang hanggang tomorrow. Okay? Pero kung tapos na kayo ng particular item, you can submit it already para ma-check ko na rin. Para kung meron akong mga minor comments that can apply to the other items, ma-incorporate nyo na siya kagad. Alright? Hindi ko pa ulit na-check yung submission bins, pero after our class today, probably I'll take a look at it. And kung medyo ganahan ako, mag-start ulit ako mag-check. Alright? Okay. So also remember I will give bonuses to those who attended the student alumni faculty forum yesterday, and those who will be attending the research webinars from IMSP on Monday. Okay. So kung nanood kayo ng SAF kahapon, might as well write a short reaction paper as soon as actually sana nga kahapon pagkatapos nagsulat na kayo para hindi siya tumambak. So kung ganun yung ginagawa ko pag marami akong kailangan gawin, what I do is I break them down into several manageable pieces para kapag meron akong say 30 minutes na free, pwede ko na gawin yung mga maliliit na piraso na yon. Tapos para mabawasan yung kailangan kong trabaho. So try to insert this little things during your free times. Kasi for instance, sa reflection paper, wala namang malalim na pag-iisip kayong kailangan gawin. So why not do it? And para out of the plate na siya. Para hindi nyo na siya isipin at hindi na sumabay sa ibang mabibigat na requirements. So I'm a bit strict about deadlines regarding incentives. So the deadline for the reaction papers would be on Monday, March 28th. After that, um, I will not accept any more submissions. Tapos yung reflection paper para sa March 28 webinar, ang deadline niya ay yung susunod na Monday. So I'll give you 1 week to write those reflection papers, okay? Pero baka tamaan pala siya ng reading break. So probably I'll put it right before the reading break. Probably April 1, yung deadline nung March 28 reflection paper. Okay? So I hope that's okay. Okay, so with those out of the way, so let's go back to where we left off last time. So I think last week we were talking about sequences, all right? And we said that sequences, these are just functions of, or functions of real numbers whose domain is the set of natural numbers. So si f ay isang sequence kapag ka isa siyang function that maps every natural number to the set of real numbers. And we said that we can represent a sequence by writing a rule, say a rule a sub n or a formula a sub n that assigns to each natural number n a, baligtad pala, that assigns to every natural number n a real number a sub n, okay? And then often it is quite convenient to list down all of the elements of a sequence in an ordered list. So kapag ka sinabi nating sequence a sub n, so, pwede natin siyang isulat ng ganito whenever it is clear in context that we are talking about sequences, alright? So, yung bracket A sa B na yan, kung ang usapan ay sequence, iti-treat ko to as a sequence. So, marami siyang laman, alright? If we are talking about generic sets, then isa lang yung laman nung netong object na to, which is A sub n. Pero kung clear nga sa context, iti-treat ko siya as sequence. So, if you want to remove the ambiguity in your writing, you can also write it as a sub n, where the index n starts from 1 to positive infinity, para mas clear that you're talking about sequences. All right? Now, whenever we want to look at the behavior of the sequence, by looking at the first few terms, we can do an ordered listing. So, kailangan A1, A2, A3, and so on. All right? Now, whenever you're writing a sequence na kamukha ng isang set, medyo kakaiba to sa isang set because when you're writing down or listing down the sequence in this manner, in an enumerative manner, sinusulat natin siya in order. So, function value ni 1, function value ni 2, function value ni 3, and so on. If two of these elements will switch places, then ibang sequence na yon. Kasi nga dapat ito yung function value ni 1, yung pangalawa yung function value ni 2, and so on. Okay? Now, whenever dealing with sequences, we are not very much interested with the first few terms. What we're looking for is the behavior of the sequence as the indices increases without bounds. So, ang gusto nating makita, ano yung behavior ng sequence dito na sa padulo. Alright? Hanggang dun sa, or what will happen as the indices becomes very, very large. So habang lumalaki na lumalaki yung mga index, ano yung nangyayari? And to quantify that behavior, we look at limits of sequences. All right. So we say that a sequence A sub n converges to a real number A, or alternative notation, limit ng A sub n as n approaches positive infinity is equal to A if and only if for all epsilon greater than 0, okay, kahit ano pang epsilon yan, there will exist a capital N coming from the set of natural numbers such that for all little n greater than or equal to capital N, we have absolute value of an minus a is less than epsilon. So what this is telling us is that kahit ano pang epsilon yung piliin mo, so even however small it is, laging kang may makikitang starting index capital N, such that pag lumampas ka na dun sa starting index capital N, yung distance mula kay A sub n papunta kay A ay mas maliit na sa epsilon. And the key there is that we can do this for any epsilon greater than 0. So kung super liit na ni epsilon, ibig sabihin yung distance o yung layo between A sub n at saka si A ay nagiging mas maliit na dun sa napakaliit na number na inelect mo later given a sufficiently large index. So habang nasa padulo ka ng padulo sa listahan, palapit na ng palapit yung mga terms ng sequence mula dun sa supposed limit A. Right? And I think that's what we did last time. Last time we looked at certain or some examples of specific sequences, proved their limits using the definition, and considered a sequence wherein hindi naman siya nagko-converge, yung sequence ng alternating -1 and 1. Okay? Now, kasi doon, ang kaso doon, nakapagpakita tayo ng isang epsilon greater than 0 such that sa lahat ng capital N lagi na lang merong index little n na mas malaki kay capital N such that this inequality is not true. Okay? So kapag ka ang isang sequence ay walang limit, so that means A sub n will not converge to any real number A, then we call that sequence a divergent sequence. All right? Kung nagko-converge siya, ang tawag natin ay convergent. Kung hindi siya nagko-converge, ang tawag natin ay divergent. Okay? So kung may limit, convergent. Pag walang limit, siya ay divergent. And to show divergence, medyo nahirapan tayo last time kasi kailangan nating gamitin yung negation ng definition ng limit plus show na kahit ano pang real number yung piliin natin, hindi siya pwedeng maging limit. So we exhausted all the possibilities para dun sa alternating sequence na yon. Wala talagang posible maging limit. And that is quite problematic because for more complicated functions or sequences, hindi ganon kadali yung magiging analysis, right? So that's why we need to establish a much easier divergence criterion. And hopefully in the lecture today, we'll be able to define or to state a divergence criterion na hindi kailangan dumaan dun sa definition. Okay? So yun yung plano natin for today. Oh, by the way, before I proceed, nakalimutan ko sabihin kanina, meron akong meron akong typo dun sa problem set. Let me just pull up the problem set quickly. Okay. Yun sa number 3, okay? Meron akong bubu na naman. Ang nasulat ko ay A intersection B is empty. All right. And if A intersection B is empty, then there's no point in finding a formula for A intersection B. Kasi essentially, ang gagawin mo lang, hanapin yung supremum at saka infimum ng empty set, which unfortunately we did not define. Okay? Meron mga conventions na ginagamit, all right, para sa supremum at infimum ng empty set, but I did not give that in class, all right? And basically, it's just a set of conventions para sa empty set. Wag yun ang sagutan etong second question, all right? Because what I intended there is dapat ang A intersection B ay non-empty para merong laman si A intersection B so that it will make sense to take a look at the infimum and the supremum. Okay? So for those who are, dahil late ko na siya napansin, okay, those who are working on number 3, do not answer this anymore. So i-avoid ko na lang yung second question. Kasi nga dapat ito yung sinulat ko. Ang nasulat ko dun sa problem set na in-upload ko ay A intersection B equals the empty set, which is trivial. If you'll think about it, you'll just need to adopt some conventions para sa infimum at supremum ng empty set. So yun, tanggalin nyo na yun sa problem number 3. Okay, siguro for next semester na lang saka ko ibabalik itong question na ito. Alright? So dahil doon, pwede nyo na rin i-disregard yung mahabang note. Kainis nga kasi ang tagal kong pinag-isipan yung note na yan, alright, kung paano siya i-describe. Tapos yun naman pala may typo ako dun sa taas. So essentially, that's it. Wag yun ang sagutan yung follow-up question sa number 3. Okay. Dahil siguro nagpa-problem set pa kayo, I will limit our discussion today to those results na medyo familiar na para nothing is new. Probably the proofs will be new, but the concept behind the theorems that we will prove ay medyo medyo familiar na sa inyo. Alright? Yun yung kagandahan sa start ng section 2 or ng unit 2. Kasi nga expected ng mga students na gagawa pa ng problem set number 1, medyo ang advantage ng unit 2 ay familiar kayo dun sa mga theorems nandun sa unit 2, especially dun sa initial parts nito. Alright? So for instance, let's look at the very first theorem that we have for this unit. Okay, which is the uniqueness of a limit. Okay. Now it says that the limit of a sequence, should it exist, is unique. All right. So ibig sabihin kapag yung isang sequence ay nag-converge sa isang real number A, then there is no other limit. Okay, unique na yung limit. Thus, we can use the article the. Okay, kasi nga unique naman pala yung limit, so pwede na yung article the. Pero if you're not sure kung wala si Theorem 2.1, then we should have been using the article a to denote na maraming posibleng limit. Pero thanks to Theorem 2.1, laging isa lang yung limit para sa mga convergent sequences. So we do have now two possibilities, all right? Pwede nating i-refine yung dalawang possibilities natin kanina. Posibleng ang isang sequence ay mag-diverge or pwede siyang mag-converge sa nag-iisang limit. So hindi posible na magkaroon ka ng dalawang magkaibang limits. And since this is a proof of uniqueness, all right? So hindi na to existence and uniqueness result kasi ang assumption mo muna mag-exist siya. So suppose that the limit exists and what we want to show here is that that limit is unique. All right? So usual trick, pag nagpo-prove tayo ng uniqueness, gagawa tayo ng proof by contradiction. All right? We will assume that there are two different limits and we want to show that those two limits are equal to each other. Okay? Via a contradiction statement. Okay? Pero yung proof pala nito, hindi niya sinulat in a contradictory manner. Okay? I-outline ko nga yung dalawang possible proofs. Okay? So dalawang possible proofs or approaches sa uniqueness. Okay? Pero ano naman to halos magkamukha yung proofs nila. Nagkakaiba lang sila dun sa format. Okay? Yung una, yung proof by contradiction. Okay? Ang gagawin mo lang, suppose that there exists dalawang numbers, say A not equal to B, such that your property holds. All right? So assume mo na meron kang dalawang numbers, magkaibang numbers, all right? A being not equal to B that satisfy the given property. So in our case, if you want to write a proof by contradiction, you will assume that there exists two numbers A and B not being equal to each other such that they are both limits of the given sequence. And you want to draw out a contradiction, all right? And usually the contradiction that we get is A equals B, which is a strict contradiction to our supposition. So ito yung unang format. Yung pangalawang format is a sort of a direct proof, pero it is hidden, parang hidden ano siya, proof by contradiction. So what you'll try to do here is that you will assume na meron kang A and B satisfying the given property. Wala kang sasabihin na si A ay hindi equal kay B. Kaya hindi siya nagiging proof by contradiction. So we will assume two numbers A and B that satisfy the property. And then using the same arguments in the indirect proof, you will be able to show that A is equal to B. Okay? Now, walang contradiction kasi hindi naman natin in-assume sa simula ng proof na si A at saka si B ay different from each other. What we did here is to show na kung meron dalawang numbers na parehas limit ng sequence, all right? Dapat si A at saka si B ay equal sa isa't isa. And that will end your proof. Okay? Pero yung arguments nila parehas na parehas. Nagkaiba lang sila dun sa formatting. Okay? So, yun yung dalawang usual ways on how to prove that that something is unique, right? Not just for sequences, but for other statements in general. Okay? So let's try to see how the handout or how the lecture notes wrote the proof. Okay. Sorry guys, kailangan ko mag-pause from time to time. Hindi ko alam, parang twice or thrice nito. Laging inaatake ako ng runny nose kapag ka nagkaklase. Allergic siguro ako sa pagkaklase. Anyway. Alright, Theorem 2.1. So proof. So yung proof niya yung medyo second variant. Direct proof. Okay, parang proof by contradiction in disguise pero direct yung pagkakasulat. So now we will suppose that A sub n converges to two numbers A and B at the same time. So we're not alluding any property to A and B. Kaya hindi siya naging strict na proof by contradiction kasi hindi ko sinabi na magkaiba si A at saka si B. Sinabi ko lang, kunwari, nagko-converge si AN sa dalawang numbers, A at saka si B. Okay? And then what we're gonna do is to apply the definition of the definition of the limit. Alright? Kasi yung pa lang yung alam natin, si AN nagko-converge kay A at saka si AN nagko-converge kay B. So by definition of the limit, given any epsilon greater than 0, there exists an n sub 1. Okay? Bakit ako gumamit ng n sub 1 instead of just capital N? Because we're talking about two different limits in here. So yung n sub 1 para kay capital A for a specific epsilon, at yung capital N para kay B for another specific epsilon, or even for the same epsilon as A, ay magkaiba. So magkaiba posibleng starting indices para dun sa subscripts, dun sa pagpapakita ng limit ni AN ay equal kay A at limit ni AN ay equal kay B, even if you're working with the same epsilon. So kaya gumamit ako ng N1 dyan, gumamit ako ng N2 rito. Okay? So there exists an N1, a natural number, such that for all indices greater than or equal to N1, yung absolute value ng AN minus the first of the supposed limits ay less than kay epsilon over 2. Now, why did I choose epsilon over 2? Well, that's for the sake of what is to follow. All right? So makita natin mamaya kasi ang idea dyan, ipag-add ko itong dalawang inequalities na to. Ito at saka yan ito. So pag ginad ko sila, magkakaroon ako ng epsilon over 2 plus epsilon over 2. That will bring me to epsilon. Okay? Now, you could have chosen to use epsilon over 3 here and 2 epsilon over 3 here. When I sum them up, you'll get epsilon. That's also fine. Kasi nga, yung definition naman ng pagiging limit ay for all epsilon greater than 0. So kahit anong epsilon greater than 0, you can find a starting index. So kung si epsilon ay arbitrary, positive number, then so is epsilon over 2. So is 2 epsilon over 3. Ganun din si epsilon over 3. So kahit anong multiple ni epsilon, pwede nyo siyang diyang gamitin. Kasi nga si epsilon ay arbitrary, i-divide mo siya or i-multiply mo siya by another real number that will give you another arbitrary real number. Okay? So if you'll be writing your proofs and siguro hindi nyo pa nakikita na kailangan ko pala ng epsilon over 2 o kailangan ko pala ng epsilon over 6 or something, pwedeng gamitin nyo muna dito ay epsilon. Okay? Pero lapis muna yung gamitin nyo. Then continue with your proof. Tapos makikita nyo later, pag epsilon yung ginamit nyo dito, saka dito, magkakaroon ka ng 2 epsilon mamaya. So, and then hindi ganun kaganda yung 2 epsilon, alright, when you're talking about things. So, malalaman mo, 2 epsilon pala yung mangyayari. So, and I got the 2 epsilon by adding the 2 different epsilons. So, kaya ko ginawa tong epsilon over 2. So, pwedeng balikan nyo yung proof, palitan nyo yung epsilon na ginamit nyo by epsilon over 2. So, yun yung mga usual tricks. Kasi minsan sa analysis, sa mga proofs, nakakabigla. Nabigla na lamang merong epsilon over 2, epsilon over 6 na lumalabas out of nowhere, alright? So, tapos makita pa lang natin later para saan pala siya. Kasi gusto mo maging epsilon yung total o yung product dun sa dulo. Okay? So, yung usual ginagawa ng mga mathematicians, except if we can foresee what is to happen, alright? Kung na-anticipate na namin yung mangyayari. Pero kung hindi namin na-anticipate, start ka muna ng epsilon. Tapos magiging 2 epsilon nga yung nasa dulo. So i-edit mo na lang later yung mga epsilons dun sa unahan ng proof para makuha mo yung total na epsilon mamaya sa dulo. And the reason why we can do that is arbitrary kasi yung pagkakapili ng epsilon. So we can play with multiples of that particular epsilon. Okay? Now, anong sinasabi natin dito? Well, given any particular epsilon over 2, all right? So, kapag lumampas ka na ng A1 ng N1, okay? So lahat dito ng mga lahat ng mga function values after N1, okay? Nandito yung mga little n's. Yung absolute value ng AN minus A ay nagiging mas maliit na kay epsilon over 2. Okay? And then kapag ka naman lumampas ka na ng N2, halimbawa, kunwari lang, andito si N2. Pag lumampas ka na ng N2, so nandito na yung mga little n's mo, alright? Dito sa portion na to, ang absolute value ng an minus b ay mas maliit na sa epsilon over 2. And then again, our business is looking at the tail end. So gusto ko ngayon magsabay na nag-hold etong dalawang inequalities na to para mapag-add ko sila. Alright, makita nyo rin later kung bakit gusto ko silang ipag-add. Alright, so I want these two inequalities to be valid, and they would be valid if I can choose the starting index large enough so that both inequalities will hold true. Right? So the trick is, tingnan mo, kailan mangyayari yung dalawang inequalities na to. First inequality happens kapag ka mas malaki na yung index sa N1. The second inequality happens kapag ka yung index ay mas malaki na kay N2. So if I want them to both happen at the same time, then I want the starting index to be at least the larger between N1 and N2. Okay? Kasi nga, pag kinuha ko yung mas malaki sa kanila, sinabi ko, eto yung starting index para dun sa main proof ko, then alam mo na nag-hold etong dalawang inequalities na ito. Right? And that's why in the proof, you will see here that I let capital N to be the maximum between N1 and N2. Okay? Kasi nga, kapag ka si N, pinili ko to be the maximum or to be the larger between N1 and N2, then if I pick a subscript little n that is greater than or equal to capital N, then that little n is sure to be larger than N1 and N2. Alright? At dahil mas malaki na si little n kay N1 at saka kay N2, then we are sure that this inequality and this inequality are both true. Alright? And then I can simply manipulate them, all right, and add them up. If I will add them, I will get this part of this inequality over here. Okay? So nakuha ko yung less than epsilon. Pero what's the nice thing about this inequality? Well, this inequality is sort of the split between absolute value of a minus b. Now, why do I know that a minus b will come into the mix? Well, remember, we're trying to show that a is equal to b. All right? So, ibig sabihin, one way to know if a is equal to b is to look at the distance between them. So, tingnan ko ano yung absolute value ng a minus b. Pwede ka dito nagsimula eh. And then you will see, a minus b, pwede ko yung isulat as the absolute value of an minus a plus an, hold on. Okay, the idea ay mag-add, subtract ako ng mga an's. So, I'll have a minus b plus a sub n minus a sub n. All right? Equal yan sa absolute value ni a minus b. Pero this guy can be written as what? I can write it as absolute value ng a minus an minus b minus, minus, meron ako negative b, no? So dapat yung negative b, pwede siyang plus an minus b. Okay? So niregroup ko lang yung mga terms. And then sabi ng triangle inequality, if you're taking the absolute value of a sum, that will be smaller than the sum of the absolute values. So pwede kong paghiwalayan ito at saka ito sa magkahiwalay na absolute values, but what I'll get is a larger expression. And that's what this is. All right? Pero alam na nga natin si capital N is larger than si little n ay mas malaki than N1 and N2. So we know that this guy is less than epsilon over 2. Then the second absolute value is less than epsilon over 2. Add them up, you'll get epsilon. Okay? So in short, what we have here is that the absolute value of a minus b is less than epsilon for any epsilon greater than 0, but the absolute value is always non-negative. So meron tayong greater than or equal to 0. Now, dito ko gagamitin yung result na lemma 1.1 mula sa module 1. Okay. Well, what does that lemma say? Recall lang natin yung lemma na yon. Ano nga yung lemma na yan? So, if A is less than B plus epsilon, for all epsilon greater than 0, then A is less than or equal kay B. Ito yung lemma 1.1. And I said, when we proved this lemma, gagamitin natin siya madalas sa mga proofs kasi isa siyang magandang characterization ng inequality or ng order kapag ka-involve ang isang arbitrary positive epsilon. Okay? Now, paano natin to magagamit? Remember, what we have is 0 less than or equal to absolute value of A minus B less than epsilon. Okay? And this is true for all epsilon greater than 0. Okay? Now, what we can do here is, okay. So, ang idea rito ay, okay, pwede ko itong isulat as 0 less than or equal to absolute value ng A minus B less than 0 plus epsilon. Okay? Nagdagdag lang ako ng 0 sa isang side. Tapos, dun sa lemma 1.1, ito si A, tapos ito yung B nung lemma. Alright? Kasi yung A, siya yung left-hand side ng inequality, yung B, siya yung naka-add kay epsilon. So, ibig sabihin, the absolute value of A minus B is less than 0 plus epsilon for any positive epsilon. So, that will mean, gamitin ko lang yung theorem, dapat ito ay less than or equal kay 0. Okay? Ito ay carried over lang mula dun sa statement, pero ito yung ginamitan ko ng lemma 1.1. So we now see that the absolute value of A minus B is less than or equal to 0, but is greater than or equal to 0. And that will mean only one thing. Absolute value of A minus B must be equal to 0. Okay? So the absolute value of A minus B is equal to 0. That means that the expression inside the absolute value must be equal to 0. And that means A is equal to B. So that guarantees na kapag ka nagko-converge yung isang sequence, then dapat unique yung limit nating makukuha. All right? So is the proof clear? Or problem set pa rin ang nasa isip nyo today? Okay. So I'll take your silence as medyo clear naman yung theorem. Okay? But that's nothing new and that's not surprising kasi alam na natin yan from Math 38. Okay? Now, let's look at a bunch of definitions. Definition 2.4, we define what the bounded sequence is. We say that a sequence is bounded if there exists a positive number m such that the absolute value of an is bounded above by m for all indices little n. So, ibig sabihin, bounded siya kapag yung absolute value ng lahat ng terms ng sequence ay mas maliit sa isang natural, sa isang real number m. Okay? So, geometrically, that means that there is an interval, negative m to m, that contains every term in the sequence. And that is obvious coming from this inequality. Remember, when you have a less than inequality absolute values, this will translate to being less than or equal to an, and an being less than or equal to capital M. Yan yung ibig sabihin ng absolute value of an less than or equal to m. So that means, indeed, all of the terms in the sequence will be bounded below by negative m and bounded above by capital M. So lahat ng terms ng sequence, kaya nating ikulong sa interval negative m to m. Okay? And then there's a nice relation between bounded sequences and convergent sequences. Okay? So in Theorem 2.2, we see that every convergent sequence is bounded. Okay? Kapag ka-convergent yung sequence, automatically dapat siya ay bounded. Okay? So that is, if the limit exists, then AN must be bounded. So which is a nice property, and I think manganganak ito ng isang divergence criterion. But let's defer that until we have proven the theorem. Okay? So assume natin convergent yung sequence. Kailangan nating maghanap ng bound, capital M, para dun sa sequence neto. All we know is that the sequence is convergent. Okay? Now, this is the nice thing. Even if we don't know where the limit what the limit is, basta alam natin na convergent siya, may nag-exist na limit na real number, we will be able to show that the sequence is bounded. Okay? So kung siya ay bounded, kaya pala na, kapag ka siya ay convergent, kaya nating ikulong yung sequence sa loob ng isang closed interval. Okay? Now, the proof is here. Let's try to read it and insert some details if need be. All right. So, okay, let's start with the assumption. Declare the assumption. Here, we know by assumption that the limit of AN is equal to A. Or let's assume that the limit exists at tawagin natin yung limit na yon ay equal kay A. And then remember, kapag ka ang limit ay nag-exist, then for all epsilon greater than 0, blah, blah, blah. All right? So this is true for all epsilon, so I'll give a specific epsilon. I'll take advantage of the universal quantifier in the definition of the limit. Say I'll take epsilon be equal to 1. Dahil equal siya kay 1, okay, then there exists an index capital N such that kapag ka lumampas na yung index kay capital N, I will have absolute value of AN minus A is less than the epsilon we chose. So alam ko na yung AN minus A ay magiging less than 1. Okay? Specific choice of epsilon, magkakaroon ako ng specific capital N. After capital N, lahat na ng terms ay within 1 unit away from the limit A. Tapos gagamit ako ng triangle inequality. All right? I know that the absolute value of AN minus A is less than epsilon, but the left-hand side of this limit is larger than absolute value of AN minus A. I guess you can see this from the different versions of the triangle inequality we have in Unit 1. Okay? Tapos ang kagandahan nito ay this inequality will imply that absolute value of AN is less than absolute value of A plus 1. Okay? So anong ibig sabihin ng inequality na sinulat ko dyan? Starting, kapag ka lumampas na ako ng capital N, so lista natin yung mga sequence, nandito si capital N. So lahat ng mga indices after capital N, sure na ako na yung mga ANs dyan ay mas maliit sa absolute value of AN plus 1. So yung mga nasa medyo dulo na nung listahan, sure ako na hindi sila lumalampas ng limit, ng absolute value ng limit plus 1. Okay? Which shows the boundedness ng mga terms na nandito sa dulo. So alam na natin, hindi sila lumalampas ng absolute value of A plus 1. So kung yun lang yung usapan, then pwede na ito yung maging capital M natin sa definition ng pagiging bounded. Kaya lang, nag-work lang tong inequality na to pag lumampas ka na nung specific capital N na dinikta nung epsilon equal to 1. Sorry. Okay. So ano pa yung problema natin? Ano yung nangyayari? Ano kaya, bounded din ba yung nauunang capital N terms? Or yung naunang capital N minus 1 terms? So ano kaya yung inequality? Or nag-hold din ba tong inequality na to sa mga little n's na nandito? Okay? The answer is not necessarily. Okay? So hindi sila lahat kailangan maging less than absolute value of A plus 1. Pero ang kagandahan kasi, finite na lamang yung mga natitirang terms ng sequence before capital N. So nandito lang si A1, si A2, si A3 hanggang kay A sub N minus 1. Ito na lang yung pinoproblema natin. Yung capital N minus 1 na terms na yan, bounded ba sila? Kasi sure na ako pag lumampas ako ng capital N, bounded na yung mga terms by absolute value of a plus 1. So ito na lang yung problema ko, kaya lang finite sila. At dahil finite sila, mga real numbers lang naman yung mga yan, so pwede kong piliin kung ano yung pinakamalaki sa kanila. Tapos yung pinakamalaki sa kanila, yun yung magiging bound para dito sa mga nasa kaliwa ni capital N. Tapos, palakihan na lang. Yung bound dito, i-compare ko dito, which is the bound for the other terms, then the larger between them would be the bound for the entire sequence. Alright? So, ginawa ni handout, ganito pa yung ginawa niya. Pinili niya si capital N to be the largest among, eto, absolute value of A plus 1, which serves as the bound pag malaki na masyado yung index. Alright? And palakihan na lang yung absolute value ni A1, A2, A3 hanggang A sub n minus 1. The largest among the absolute values of these and the absolute value of A plus 1 will serve as our capital M. And for sure, kung si capital N is chosen that way, we know that the absolute value of AN will be less than capital M. All right? And that means the sequence is indeed bounded. End of proof. Ang bound niya ay absolute value of A plus 1, the limit plus 1, or the absolute value of the first n minus 1 terms, or the maximum among those absolute values. Okay? Any questions? Masyado kayong tahimik ngayon, ha? Feeling ko nagagawa kayo ng problem set dyan sa tabi, no?
Di naman po, sir.
Okay, yeah. Just joking, David. Yeah.
hindi ko po question din po, sir.
Sige lang.
Parang hindi ko po I don't know what I'm missing, but so ang tinitignan po natin is yung maximum ng first n minus 1 terms. Tama po ba?
At saka, maximum nila versus yung absolute value ng A sub n plus 1. Kasi di ba ang goal natin ay maghanap ng isang number na mas malaki sa lahat ng terms ng sequence. Alright? Tapos sure ako, by definition ng limit, kapag yung subscript ay mas malaki na kay capital N, yung absolute value ng mga ANs ay mas maliit dun sa limit plus 1 or sa absolute value ng limit plus 1. So sure na ako dyan. Ang hindi ako sure ay yung mga mabababa yung index kung sila ay mas maliit din sa absolute value of A plus 1. Alright? Ang ginawa ko, para sure ako na makakuha ng isang number na mas malaki sa lahat ng terms ng sequence, pinili ko si capital N to be yung pinaka-among this absolute value of A1, absolute value of A2, absolute value of A3, hanggang absolute value ng A sub n minus 1. Yung maximum na to, sure ako nag-exist. Kasi finite lang naman itong mga pinagko-compare ko. So pwede nyo isipin by what? Total order sa isang finite set. Lagi kang may makikitang maximum. Pero kasi kung infinite yung laman, kung infinite yung set na hinahanapan mo ng maximum, posibleng hindi mag-exist yung maximum. Alright? Kaya kailangan ko siyang i-reduce into a finite set. Dapat finite lang yung candidates para maging capital M, para sure ako na may nag-exist na maximum. Kasi kung infinite yung dami ng candidates, hindi na ako sure na yung maximum ay mag-exist. Kaya kailangan kong gamitin yung pagkakaroon niya ng limit. Alright? Kasi kung wala siyang limit, hindi ako sure na siya ay magiging bounded. Requirement na dapat convergent siya muna. Okay, so I hope that makes it clearer. Okay. Now, I was mentioning earlier, posible tayo dito makakuha ng isang divergence criterion. And yeah, that's true by using the contrapositive of Theorem 2.2. Remember ang contrapositive, pag meron kang P implying Q, alright? Equivalent yan dun sa tinatawag natin na contrapositive niya. Ang contrapositive niya ay not Q, implying not P. Right? So yan yung contrapositive ng P implying Q. And this is the principle we used when we prove things using a proof by contraposition. Right? So instead of proving the statement, ang pinuprove natin ay yung contrapositive niya. Kasi sila nga ay logically equivalent lang. All right? Parehas lang sila from the logic point of view. So if you go back to Theorem 2.2, it says that convergent sequence implies sequence is bounded. So parang convergence implies boundedness. So if we'll take the contrapositive, if a sequence is not bounded, then it is not convergent. So that's an equivalent statement to 2.2. So that's one thing that we can use to prove divergence. Na kapag ka siya ay hindi bounded, automatic siya ay divergent. Okay? Pero kung siya ay bounded, hindi automatic na siya ay convergent. Okay? At hindi rin naman, ano yung sabi ko? Yeah, kapag ka siya ay bounded, hindi siya necessarily convergent. Kung siya ay bounded, hindi rin siya necessarily divergent. Okay? Yun naman yung converse ng Theorem 2.2. Yung contrapositive, laging totoo. Not bounded implies not convergent. That's the contrapositive, so we're sure that that is true. But the converse is not always true. Ano yung converse ng Theorem 2.2? Ang converse niya ay kapag ka siya ay bounded, automatic convergent. So can you give a counterexample to that statement? Makapagbibigay ba kayo ng isang bounded sequence na hindi naman convergent? Sige nga, for bonus points. Can you give me a bounded sequence na hindi convergent para ma-disprove natin yung converse ng Theorem 2.2? Kasi baka naman pala pwedeng maging if and only if yung Theorem 2.2. Right? So can you give me a bounded sequence na hindi convergent? Sige, bonus points. Habang hihigop muna ako ng kape. Oh, right. Ang bilis naman ni David. Yeah, that's correct. David is right. Oops. Kailangan mo sigurong i-edit, David. Kasi convergent yan. I think you meant the other way around. So yeah, David, edit mo yan. Kasi yung sequence na binigay initially ni David ay 1 to the negative n. So yung 1 to the negative n, siya ay bounded. Kasi pag sinimplify mo yung negative, pag sinimplify mo yung 1 to the negative n na sequence, ito lang ay sequence. Yeah, ito ay sequence na 1, 1, tama ba? Yeah, 1 to the negative 2, 1 to the negative 3, 1 to the negative 4, and so on. Puro 1s lang. But a sequence of puro 1, siya ay magiging convergent. So yeah, ito ay isang bounded sequence na convergent. So, well, may chance pala na maging true yung converse. Pero yung converse, hindi siya laging totoo. So, yun yung hinanap kong counterexample. Sequence na bounded, pero divergent. Yeah, I think that will work. Yung edited version ni David, yeah. Negative 1 to the power negative n. Or actually, pwedeng n na lamang. Alright. Pero sige, sundin natin si David, negative n. So ito lamang ay yung sequence na negative 1, 1, 1, negative 1, and so on. Alright? This sequence is bounded kasi nag-alternate lang siya between negative 1 and 1. So we could have chosen capital M to be equal to 1 or capital M to be equal to 2. Alright? So makukulong natin yung terms ng sequence sa closed interval negative 1 to 1 o sa closed interval negative 2 to 2 and so on. Alright? And we have proven earlier that this is divergent. Okay? So, bounded, pero divergent. So, ibig sabihin, hindi automatic na pag bounded ay convergent. Pero pag convergent, automatic bounded. Tapos pag hindi bounded, automatic na divergent. Alright? Pero again, kapag ka siya ay bounded, hindi automatic na siya ay na siya ay convergent. Later, in a later section in this unit, we'll see ano yung kailangan kong idagdag para sa boundedness para maging convergent yung sequence. Kasi yung pagiging bounded ay hindi enough para mag-guarantee na siya ay convergent. Pero makikita natin later na pag dinagdagan ko pa ng isang property yung boundedness, then I can guarantee convergence of the sequence. All right. All right, so maybe let's take a 2-minute break, okay? Before we continue to a next section. Hopefully matapos natin yung section 2.2. Para next on Thursday, we're going to start with 2.3. And again, section 2.2 will not be very new. These are just the limit theorems for sequences. And most of these ay nakilala nyo na from Math 38, okay? But before that, 2 minutes break muna tayo. Habang naka-break, meron bang ano yung pinakamahirap sa tingin nyo sa problem set 1? Some might say yung problem number 1 yung pinakamahirap. Pero yung mga naging estudyante ko dati, alam na nila na mahilig ako sa mga essay questions. So, laging may required essay question. Para nung sa 155 ko last semester, nagbigay yata ako sa isang problem set, nagbigay ako ng 5 questions. Tapos they need to choose only 3. Okay? And one question in that is, I think it's very similar to question number 1 in our problem set right now. And to my surprise, yung number 1, yung essay question, siya yung may pinakakakaunting nagsagot. Most of them opted to do the proving stuff, right? So, di ko sure pero yeah, minsan mahirap nga siyang i-explain, no? Lalo na if you were asked to explain it in your own words. So, but I think it is some skill or some competency that you need to gain. Kasi I think that's one nice test of whether you really understood the topic by heart. Kung kaya mo siyang i-explain in your own words. Well, you can do the proof. Actually, you can do the proof even without appreciating the actual statements. Kasi nga medyo kaya mong i-prove yan mechanically. Na nagsosolve ka lang na nagsosolve. Okay, mapapakita mo yung mga inequalities and so on. You might be able to prove it. Okay, pero ayaw natin mag-produce ng mga robots na naka-template lang yung kayang gawin or mechanical lang yung kayang gawin. So you need to be able to appreciate what these statements are about, ano yung mga konsepto by attaching to it a layman's explanation or a visual representation. So kaya lagi ako may essay question. Kahit math course pa yan, lagi ko yan nasisingitan ng essay questions because I really want to see if you can explain in your own words yung mga concepts na meron tayo. Okay, so let's go back and look at some set of limit theorems. I think we have 2 sets of theorems here. Una yung mga algebraic limit theorems, which will tell us the arithmetic of limits. And then the second would be order theorems, which will tell us ano naman yung less than relations or about limits. Okay. So, but again, nothing is new here. These are things that you probably have used in Math 38. So tingnan natin and basically let's rummage through their proofs. Okay. Okay, theorem 2.3. ang limit ng okay. But before we go to the statements themselves, let's look at the assumptions, okay? Unang assumption, convergent yung sequence AN. Nagko-converge siya kay A. Tapos meron ka pang isang sequence BN na nagko-converge naman kay B. Tapos si C is chosen to be a constant, okay? Then we have the following results. Una, ang limit ng sum ay sum ng limits, okay? So if you know that your two sequences converge, then kapag ka binuo mo yung sequence consisting of the sums of the corresponding elements between the two sequences, so meron ka ngayong bagong sequence, A1 plus B1. Tapos second term dun sa bagong sequence, A2 plus B2, and so on. Then that new sequence will converge to the sum of the limits of the two sequences. Or of the two sequences. Okay. Tapos, may analogous property naman para sa product. Pagka kinuha mo naman yung sequence consisting of the products of corresponding terms, then that sequence will converge to the product of the limits. Okay? Third, kapag ka meron kang convergent sequence, minultiply mo lahat ng terms ng sequence by a constant, then we are sure that that new sequence will converge to that constant times the limit of the original sequence. And then lastly, for D, if you take the limit, if you take the sequence consisting of quotients of corresponding terms in the sequences, then that sequence will converge to B over A, provided that AN is not equal to 0 for all N. Paki-edit na lang. Okay. Kasi kailangan define yung quotient sa lahat ng A sub n para magkaroon tayo ng well-defined sequence. So dapat pala ito ay Bn over An, where An is not equal to 0 for any little n. Para well-defined yung quotient na Bn over An, tapos kapag lahat ng An ay hindi equal kay 0, then what? Sorry, di rin ako sure doon. Lagay ko rin dito. And A is not equal to 0. Alright. So ayan, lahatin ko na. Kapag lahat ng terms dun sa sequence ay hindi equal kay 0, tapos yung limit ng sequence AN ay hindi equal kay 0, then the limit of Bn over An is equal to B over A. Okay? So yun yung mga kailangan ko idagdag na restrictions. Okay, so let's try to prove some of these. Okay. So una, siguro umpisahan natin dito sa part A. So remember, ang assumption natin dito ay limit ng AN ay equal kay A at limit ng BN ay equal kay B. Tapos gagamitin ko yung definition ng limit. Alright? In the same manner as what we did before, kailangan ko ng dalawang magkaibang starting indices kasi dalawang magkaibang sequence at dalawang magkaibang limit yung pinagtatrabahuhan natin. Okay? Though we can work with the same epsilon for these two guys, pero dahil magkaiba yung sequences, sure tayo na dapat yung starting limit for any given epsilon should be different between the two. Okay? So kailangan ko magkaroon ng capital N1 such that kapag yung index ay lumampas na ng N1, yung distance between AN and A should be less than epsilon over 2. Now again, sa definition, epsilon lang yung nandun, right? But I am dealing here with two sequences at makikita nyo mamaya, ipag-a-add ko itong corresponding sides ng inequality na to. So I will have epsilon plus epsilon. I'm gonna have 2 epsilon in the end. Pero gusto natin ay epsilon para mag-swak siya dun sa definition ng limit. Okay? Pero dahil totoo naman yung definition or dapat totoo yung inequality for all epsilon greater than 0, then if epsilon is positive, then epsilon over 2 is also positive. So for epsilon over 2, there should exist a capital N1. Alright? So, okay pa rin yun. Kasi nga for all epsilon naman, so kay epsilon over 2 may mag-exist na starting index, say capital N1. Then ganun din dun sa kabila, kaya lang kailangan ko ng ibang starting index. Starting index N2, such that Bn is within epsilon over 2 units away from B. Tapos again, ang idea ko dito ipag-a-add ko sila. Makikita nyo ba mamaya kung bakit pwede ko pala silang ipag-add. Okay? So, ipag-add ko sila. So, kailangan maging totoo muna silang dalawa para sa specific little n. Okay? So, magiging totoo sila kapag si capital N ay pinili ko to be the maximum between N1 and N2. Okay? So, I hope nakikita nyo na ngayon kung bakit kinukuha ko lagi yung maximum. Alright? Or at least sa mga proofs na ginawa natin, bakit I am after the larger between N1 and N2. Alright? So pag pinili ko kasi si N to be the larger between N1 and N2, then for all capital N larger than capital N, I am sure that that little n is larger than both N1 and N2. At dahil si little n mas malaki na kay N1 at saka kay N2, etong dalawang inequalities na to ay mag-hold. Okay? Now, before I do that, then tingnan ko muna ito. Actually, pinagsabay ko siya. Tingnan ko yung, di ba, ang sa definition ng limit, ang gusto natin ay an minus limit less than epsilon. Okay? Pero in this case, we are dealing with a different sequence. We are dealing with the sequence of sums. So, ibig sabihin, ang terms ng sequence natin ay an plus or minus bn. Alright? So, yan yung sequence na pinaglalaroan natin. Tapos, yung limit, yung claimed limit ay a plus or minus b. Okay? So, ito yung gusto nating makita. So, gusto nating ipakita na ito ay totoo. Okay? Tapos, I'll just rearrange some of the terms inside the absolute value. So, I can write it as absolute value ng an plus or minus bn minus a minus plus bn. Alright? Dinisibute ko lang yung negative sign over the group. Tapos gagamit ako ng triangle inequality. This is less than or equal to an minus a tapos plus absolute value ng bn or plus or minus bn minus plus bn. Okay? Alright. And then, para lang mawala yung maraming sign dun sa second group, I can write it as equal kay absolute value ng an minus a. Then, I'll factor what? I'll factor a positive 1. Hold on. Baligtad pala. Dapat pala to ay b. Okay. Now, if I will, paano ko matatanggal yung mga sign dito? Well, this guy is equal to either bn minus b or negative bn plus b. Alright? Kasi pagka plus, dapat minus yung kabila. Kapag ka minus yung una, dapat plus yung kabila. So there are two cases, absolute value of bn minus b or absolute value of negative bn plus b. Right? But look at this second thing. Okay? I can factor out a negative 1. So ito yung magiging absolute value ng negative 1 times bn minus b. Alright? Tapos, product ng absolute value ay, ang absolute value ng product ay product ng absolute values. So pwede ko silang paghiwalayin sa dalawang absolute values. Absolute value of negative 1 is equal to positive 1. So essentially, the second case is absolute value of bn minus b lang. Okay? So kaya, naging ganito na siya. So naging an minus a, that's from the first term there. Okay? Tapos yung pangalawa, that's kung saan equal yung dalawang terms. Okay? yung dalawang terms na merong opposite signs. Okay? So we have recovered these two guys. But from the definition ng limit, we have seen that this guy is less than epsilon over 2. And then the second guy is also less than epsilon over 2. So the sum will be less than the sum of 2 epsilon over 2's. So that will be equal to epsilon. So what we have shown here is that for any epsilon greater than 0, there exists a capital N, okay, which is chosen to be the larger between N1 and N2, such that for all N greater than or equal to capital N, this absolute value is less than epsilon. But again, this guy is the terms in the sequence minus the supposed limit. Kaya sure tayo, true na yung statement number 1. Okay. Again, by definition pa lamang ng limit ng sequence. All right? Now, let's try to prove part B. Pero dun sa proof nagkabaligtad yata. So ito dapat yung part B. Tapos ito dapat yung part C. Okay? Yeah. Let's do part B kasi interesting yung part B. And I think you can write the proof for part C by using the proof from part B as a pattern. Do kailangan pa siyang pattern? Mukhang hindi naman siya kailangang pattern. Madali lang naman siya. May hint naman dyan. Dapat ito yung mapakita yung inequality, alright? But here you will see exactly what would be the epsilon that you will choose for an minus a, alright? Kasi dito makita nyo absolute value of an minus a will be less than epsilon over absolute value of c. But epsilon is arbitrary, so epsilon over the absolute value of c will be arbitrary as well. So I think you can write the proof for part C without any problems. So let's try to look at the proof for part B. Now, ano nga ba yung part B? Ang sabi ng part B, ang limit ng an times bn as n approaches infinity ay equal kay ab. Yan yung gusto natin ipakita. So essentially, what we want to show here is that for all epsilon greater than 0, there exists a capital N such that ang absolute value ng an times bn minus ab ay less than epsilon. Ito yung gusto nating ipakitang inequality. Okay? Now, how will we get here? Medyo may trick na kailangan gamitin. Okay? Now, let's see. So, ito lang yung assumption natin. Ang assumption natin ay convergent si an at saka si bn. Alright? Now, here's the trick. We notice first that since, again, by assumption, an is convergent, right? Dahil convergent si an dapat ay bounded by Theorem 2.2 if I'm not mistaken. Okay? Tapos, dahil si an ay bounded, by definition 1.4 ng pagiging bounded, then sure ako na may nag-exist na positive real number capital M such that capital M is greater than or equal to an. Okay? And then, bakit may B? Kailangan ko ba yung B? Let's see. Bakit may sumingit na absolute value of B dyan? Kailangan ko nga ba siya? Yeah, I think I'm gonna need that. Pero madali lang naman. Pero kailangan ko mag-insert dito, alright? Sige, insert natin tong part na to. Okay. So, step by step natin gawin. So si an ay bounded. So, kasi si an ay convergent. So siya ay bounded. Okay? So, dahil siya ay bounded, there exists an M1 greater than 0 such that absolute value of an is less than or equal to M1 for all little n. Okay? Pagiging bounded. Tapos, I will take capital M to be the maximum between M1 and absolute value of B. Okay? Lagi kong gustong magkuha ng maximum sa isang finite set lamang. Kasi sure ako nag-exist yung maximum ng isang finite set. So in this particular case, I'm going to choose capital N to be the maximum between the upper bound for AN, which is M1, and the absolute value of B. Now, bakit ko gustong gawin to? Kasi if M is chosen this way, then I am sure that capital M is larger than both the absolute value of AN and the absolute value of B. Makita nyo mamaya kung bakit gusto ko yung inequalities na yan. Okay? But M is a positive real number, so epsilon over M is a positive real number. So with that choice of epsilon, okay, or with that choice dun sa definition, so meron nag-exist na N1, gagamitin ko na naman yung definition ng sequence kay AN, ng limit ng sequence kay AN saka kay BN. Tapos ang epsilon kung pipiliin ay epsilon over 2M. Kasi si M ay positive. Okay? So ibig sabihin, si epsilon over 2M ay isang positive real number. So para dito sa real number na to, may mag-exist na starting index such that whenever we are beyond that starting index, the distance between the terms and A will be less than epsilon over 2M. Tapos ganun pa rin kay KBN. May makikita naman akong starting index N2 such that this guy is true. Okay? Nakikita niyo yung mga tricks na ginagamit rito. Now, bakit gusto kong epsilon over 2M? Makikita niyo later kung bakit ko gustong yan yung gamitin. Okay? So thus, if we choose capital N to be the maximum between N1 and N2, then for all little n greater than or equal to capital N, we have the following inequality. All right? Now, start ako sa AN, BN minus AB. Again, I start here because that's what I want to show that is less than epsilon. Pag napakita ko na ito ay mas maliit kay epsilon, then by definition of the limit, we're done. All right? So, dahil doon, dito ako nagsimula, kailangan ko itong i-manipulate. I-manipulate in what way? I want to get the product of these two things. All right? So mag-start ako rito, gusto ko magkaroon ng something na involving these two inequalities para later pwede kong i-manipulate din yung mga right-hand sides nila. So dito papasok yung paghahanap ng mga tricks. Okay? Now, ano yung mga tricks natin kailangan gamitin? Well, una, mag-add and subtract ako nito. And you will see later why. Ito yung mga usual tricks sa analysis proofs na mukhang out of this world sa start, pero pagka ginagamit nyo siya palagi ng palagi, magiging natural na sa inyo na baka gagana itong trick na to. Mag-add and subtract ako ng something. In this particular case, I will be adding and subtracting AN times B. Okay? So, I hope you are convinced na equal sila sa isa't isa. Okay. Tapos ngayon, gagamit ako ng triangle inequality. So rito, I grouped the first two terms and I factored out AN. Kaya siya nagkaroon ng AN sa labas, tapos absolute value ng BN minus B. Then I grouped the remaining two terms together and they have a common factor B. So nilabas ko si B, nagkaroon ako nito. Now, this will tell you why I wanted to add and subtract AN times B. I did that so that after factoring and grouping some terms and using the triangle inequality, nakuha ko to, tapos nakuha ko to. Something na magagamit ko yung inequalities mula dun sa pagiging convergent ni AN at saka ni BN. Okay? Now, before going there, I want to use the fact that the absolute value of AN and the absolute value of B are both bounded above by B. Remember our choice for M here? Okay, yan yung pinili natin na M. So, ibig sabihin, si AN, mas maliit yan kay M. Tapos si absolute value of B, mas maliit siya kay M. So I replace those factors by something larger, so the resulting number will be larger than the previous number. Okay? Tapos ngayon ko gagamitin yung inequalities galing dun sa definition ng sequence. Definition ng limit ng sequence. Okay, what are they? Well, absolute value of bn minus b. This is less than epsilon over 2m for sufficiently large n. But we did choose capital N to be the larger between N1 and N2. So sure ako na si little n, kapag ka siya ay mas malaki kay n, mas malaki siya kay N2, so mag-hold yung Bn minus B as absolute value less than epsilon over 2m. Tapos ganun din, yung An minus A, kasi nga yung n, yung little n is large enough so that this guy becomes less than epsilon over 2m. Tapos dito nyo makikita kung bakit epsilon over 2m yung ginamit ko dun sa definition ng limit. Kasi nga, nakita ko, dito nagkaroon ako ng multiplier na m's. So if I multiply them out, the m's will cancel each other out. Here, the m's will cancel each other out. And then I'll have epsilon over 2 plus epsilon over 2. I'll get epsilon as the sum. So essentially, what we have proven here is that this guy is less than epsilon. Okay? Dahil less than siya kay epsilon, so kung ito yung sequence, then sure tayo ito yung limit. So the limit of an times bn as n approaches infinity is equal to a times b. All right? So, yeah. Tandaan nyo itong usual trick na to. Yung pag-add and subtract ng isang specifically chosen number. All right. So dun sa mga proofs yung proof natin kanina ng theorem part A, nag-add and subtract din tayo. Tama nga ba? Or hindi pa ba? Hindi pala ako nag-add and subtract doon. Simpleng split lang nung absolute value using the triangle inequality. Pero rito, yeah, usual trick to, nag-add and subtract ka ng something. In this particular case, I added and subtracted an times b para pag nag-group ako into two groups, tapos in-split ko yung absolute value, I can do factoring by appropriate terms. Okay. So usual trick yan. Take note of that. Maybe we will encounter that trick again. Okay. So any questions? Huwag kayo masyadong mag-alala kung ngayon hindi nyo pa, sa tingin nyo, hindi nyo kayang maisip to kagad, alright, na mag-add and subtract out of the blue. Sa lahat ng daming bagay na pwede kong gawin dito, bakit ako nag-add subtract ng an times b? Well, I hope that, or I want you to take away from this is, bakit ito yung in-add or subtract ko? Pag nakita nyo yung proof, alam nyo na kung bakit yun yung in-add and subtract ko, alright? But, wag kayong ma-depress kung feeling nyo hindi nyo kayang maisip na kailangan nyo mag-add and subtract when you try to write proofs on your own. Usually it will become a force of habit later when we're doing it over and over again. Parang malalagay na yan sa isa sa mga option na pwede nyong gawin na pag nagpo-prove ka, na stuck ka, parang papasok na sa isip mo, baka naman pwede ako mag-add and subtract ng something because that's a usual trick that we encountered or that we will encounter a lot of times in Math 155. Okay? So yeah, I think that's the end of the algebraic theorems. Sabi ko, sana matapos natin yung order limit theorems, pero isang theorem lang naman yan, pero ayoko na, napagod na ako. I mean, lakas makapagod pag may runny nose. So, hindi rin ako mapakali. So, I think we can stop here and start our discussion on Thursday by the ordered limit theorems. Okay? So, may mga pahabol bang questions? Okay, so, yes, David.
So doon pala dun sa theorem, dun sa addition po. May question pala ako, sir. Paano po mag-interpret yung ganyan pong may plus-minus? Ano po kaibahan niya dun sa minus-plus?
Kapag, usually ginagamit natin yung minus plus to denote a specific order. So halimbawa, yeah, actually that's a good question, especially if you're not too familiar with these notations. Yung absolute value ng AN plus or minus BN minus A minus plus BN. Okay? Wala palang N dun sa huli. Alright. So it's interpreted this way. Kapag ka plus yung nandito, dapat minus yung nasa kabila. So parang ano sila, ito yung specific ordering. Kasi nga yung AN plus or minus BN, hindi nagma-matter yung order dyan kasi or yung connective. Pero pag may isa pa na meron nakasunod sa kanya, pero minus plus yung kasunod, alright? Ibig sabihin, pag plus yung nasa gitna nito, ang kapartner niya ay yung minus. Tapos pag minus yung nandito, plus yung kapartner niya. So ibig sabihin, you can break this down into two cases. The first one is AN plus BN minus A minus B, or AN minus BN. So yung nasa ilalim yung ginamit ko. So dun sa pangalawa, yung nasa ilalim din ang gagamitin ko. Minus A plus B. Right. So yan yung dalawang cases. So ibig sabihin, kung yung taas yung pinili mo sa una, dapat yung nasa taas din ang pipiliin mo dun sa pangalawa. And so on. So ganun natin ginagamit yan. So pag may mga formulas na involve yung plus or minus at minus plus, ibig sabihin, ang magka-partner ay yung plus at minus at saka yung minus plus. Okay?
Okay po. Thank you, sir.
Alright, parang may ganito tayo sa 175, no? Yung R plus at saka R minus nung nag-rationalize ng numerator nung quadratic formula. So yung R plus doon, siya yung may minus dun sa denominator. And so on. So kasi dapat magma-match yung order. Okay? Yun nga pala dun sa problem set, sinuspend ko muna yung display ng answer dun sa true or false. Okay? So kung gusto nyong makita kung saan kayo tama or mali, i-take note nyo yung sagot nyo, copy nyo, kasi hindi magfa-flash yung final answer. Siguro, pag nag-close yung submission, ipapakita ko sa inyo yung solution dun sa true or false. Okay? So, i-visit nyo siya siguro tomorrow morning para makita nyo rin yung explanation kung bakit true yung sagot o bakit false yung sagot. Pero winitold ko muna kay Canvas yung pagpapakita ng solution. Alright? Para hindi kayo matempt na i-share sa classmates nyo yung sagot dun sa true or false. Okay? So, pero I don't think that is a big issue. Siguro next time i-open ko na siya automatically para pagka-submit nyo nung true or false, makikita nyo na kagad yung explanation kung bakit true or bakit false yung statement. Okay? Pero winitold ko siya ngayon para hindi kayo matempt na i-share. But I don't think you will share it with your classmates. Nakakapagpasa. So, hindi ko na yung display. Alright? So, any other concerns or questions? Overtime na rin pala. Okay, so if there are none, so thank you guys for joining me today. Enjoy the rest of the day. Good luck on the remaining problems in your problem set. And let's see each other again on Thursday. Okay? Bye, guys.
Thank you po, sir.
Thank you po, sir.
Thank you po, sir.